Okay. Alright guys, I am going to try out some new ideas today. We are going to be moving into Chapter 3 these next few weeks. And so I'd like to go over on Chapter 3, Lesson 1. We are going to be discussing what's my rule. Our lesson objectives today, we are going to solve addition and subtraction problems, solve multiplication and division problems, use rules to complete what's my rule tables, and use words and symbols to describe and write rules for functions. So our very first thing we need to think about is we're going to be thinking with algebraic thinking. This is where our brains have to think a little bit outside the box. Some numbers are going to be missing and we're going to have to try to fill them in. As you can see on our page, our first screen, we have the function machine. We're going to be listening to lots of information coming in about what the function machine actually means, but I wanted to give you a visual because this is something that was taught in the 2nd and 3rd grade levels of the everyday math. And as 4th graders, we have not had that opportunity yet to learn what the function machine actually is, so I'm going to give you a quick mini lesson over what that means today. The function machine is this area right here. In everyday mathematics, it's an imaginary device that receives input numbers that are coming in, and pairs them with the output numbers according to a set rule. So we're putting money into a jar and taking it out, okay? And so what we've got to do is we've got to figure out what numbers are going in and what numbers are coming out, and then figure out what the correlation is. What is the rule that we have that is helping us to get to our out after we've put something in? So let's take a look at our first one. Our math message today is each person in the United States uses about 50 gallons of water per day. We're going to use this information to complete the table. So if we take a look at this section here, we don't know our rule, we don't know what is being put in, and we don't know what's being put out. But if I read up here, I can see that there's about 50 gallons of water per day. So I know that my in is going to be my days. Okay, bear with me, Mrs. Gardner is learning to use a new tool. And just like everything else, when we are learning new tools, sometimes there are small issues that we have to learn to overcome. Okay, so I know that each person in the United States uses about 50 gallons of water per day. And I know this from my math message, so I'm looking at my rule and my in and my out. So for 2, in 2 days, how many gallons of water will we use? Okay, each person. So I'm going to do this with an actual number story so I can try to figure it out. I know that 2 times, yes, I said times or multiplication. I know some of you are going, oh no, we're moving into multiplication. But don't worry, they're not scary, they're just numbers. And I know that 2 times something equals 100. Okay, so 2 times something equals 100. Well, I know what that something is because my math message already told me if I just read it again. Each person in the United States uses about 50 gallons of water per day. So in 2 days, how many gallons of water might you use? Well, 2 times 50 equals 100. Okay? So I know that my rule is going to be times 50. That's my function machine. So I know that my new rule is going to be times 50. And I'm just putting an X there to remind myself that I'm using the multiplication button whenever I am trying to figure this out. Okay, so my next number would be, let's say we use 6 days. Oop. So in 6 days, that seems like an awfully big number, I think, in my head. So let me work it out. 6 times 50. And I know that I'm using 50 because I know that my rule is 50. In goes my number of days. My rule will be 50, and out will come the number of gallons I will use. So I look at this number, 6 times 50, and I've got a little trick that always helps me when I multiply my zeros. Drop him off, cross him out, and now I've got 6 times 5, and that equals 30. But once it's all together, because I still have my 0 hanging out over here, it's 300. So I know that this out will be 300 gallons. Okay, let's try one more. So let's say in 10 days. In 10 days, how many gallons of water will one person use in the United States? So 10 days times my rule, 50. Did you see how I double-checked and cross-checked my function machine? I checked to make sure I was looking at the right rule. 10 times 50. Oh, look, and I have 2 zeros. And I can drop my 2 zeros over here. This is just one way you can do it. You don't have to do it if you know how to do these easily. But I like to get them out of the way so I can look at a smaller problem. 1 times 5 is 5. So I know that 10 times 50 will equal 500. So I know in 10 days, the average person in the United States will use 500 gallons of water in 10 days. Wow, that is an awful lot. This kind of makes me wonder, maybe we can think about ways in class that we can conserve water to lower our number of gallons each day. That might be something we could talk about in science. Okay, now that you've got just a quick overview, I would like to point out that I did add an extra chart up here for you to be able to use and look and refer back to, that you can look at the different types. In the type 1, we have the rule and our in. And we would have to figure out how to get to our out. What is coming out once we put in our rule? In type 2, we know our out and we know our rule. So we've got to do the opposite of what our rule tells us in type 2 box to figure out our in. In type 3, we have our in and our out, but we didn't know our rule. So you can see in pink, they told us what that was once they figured it out. We're going to have an opportunity to go through each type of those today and run through a quick lesson of how we get it done. Okay, so in type 1, it gives us our rule, and we also have our in. So 30 minus, subtraction, 15. I know that is 15. Okay, 90 minus 15. And this one's a little trickier for me. I don't really just know that right off the bat, so I better stack them up. And I'm just going to check them out. Maybe I want to do some column subtraction. It's kind of hard to do with this pen. Okay, 0 minus 5. Oh, I don't think I can do that one. I'm going to have to borrow. Bigger bottom, better borrow. 8. We'll go here, and I'm going to carry that extra 10 over on this side. So now I have 10 minus 5, and that equals 5. And 8 minus 1, and that equals 7. So I don't confuse you. I'm going to try to turn that number into a 7. Okay, so I know that 90 minus 15 is 75. Okay, now maybe you and your parents can work on these two on your own. Type 2. Add 100 is my rule. And here is my out. So here's the way we do this when we have the out and our rule. We can look at it as doing the opposite of what our rule tells us. Okay? And that might be the easiest way to think about it. So instead of adding 100, I'm actually going to take out 100. Okay? because I know that when the number came in, it was 100 less, because my function machine will add 100 to it, and this is what will pop out. So 350 minus 100, that's kind of a scary looking O, 0, minus 100 equals 0. 5 minus 0 is 5, and 3 minus 1 is 2. So I know that going in, the number was 250. Okay? Then once it was in my function machine, 100 was added to it, and it equals 350. That's what came out. Okay, so if I look at number 2 in this, 120 minus 100, ooh, that one's kind of easy for me. I know when the number came in, it was 20. And I knew this because I look at my hundreds place, and I just had 1. And I knew if I took that out, I would have 20 left. Now you can pause the video and maybe you and your parents can work on these two. Okay, type 3. This one we know the in and the out. We just don't know what the function machine does to this number coming in to make it leave coming out. So we've got to figure that out. So I'm going to take a look and try to just process through my thinking as I'm going through. So I'm looking at 7 and 49. 7 to 49. Well, I know this one is a football fact, and that means there's 7 points in a touchdown with the extra kick. And there's 7 laces on the ball, so 7 times 7 equals 49ers. Oh, 7 times 7. Well, let's see if that rule would work for 2 and 14. 2 times 7 equals 14. Okay, well, let me think about that. 2, 4, 6, 8, 10, 12, 14. That worked. Okay. Let me just double check one more time. 9 times 7 equals 63. Well, the 9s are really hard, but I do know a little trick for the 9s that might help me. So I'm going to try it right here. So I know that with 9s, if I start out, I say 0, 9, 1, 8, 2, 3, 4, 5, 6, 7, 8, 9. I've got to, oh, and I can't forget my 0. Now I have to come back up here, and I go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Oops, there's my 0. I don't need it down here. Okay, so I knew that 0, the 9s have a lot of tricks that can help, and this is just one of them. So I did know that 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and start again at the bottom or back at the top, counting backwards or counting up, would help me to figure out my 9s. So I look at 63, and let's count down. 1, 2, 3, 4, 5, 6, 7. So yes, 9 times 7 works. So I know that my rule is times 7. All right. Now type 4 is actually our trickiest one, because this one is going to be a little more difficult because we don't know our rule and we don't know all of our ins or all of our outs. So we're going to have to play with it a little bit. But I already see something that's going to help me a little bit, because I've already done my 9s, and I see a 9 here, so I'm just going to quickly look over and see if I can find a 54 in the chart that I already made. And hey, look, whenever I work something out and I leave it on my scratch paper or on the area I'm working with, I might be able to reference it again and be a resourceful crew member. So I'm looking at 54. Oh, I see 54. Okay, so I know 54 and 9. Well, 54 times 9 or times 6 would be a bigger number than 9. So I know that couldn't be times. But 54 divided by 6 would work. Okay, so I'm just going to put a little note here to myself because this one's a little trickier and I just want to keep track of my thoughts. I know that divided by 6 worked for that one. Okay, so I'm going to go down to the next one that's completed. This one looks a little trickier. 24 and 4. Okay, well, I'm going to check to see if my divided by 6 will work, because if it does, then I'm going to give it a shot with my other two. So 24 divided by 4. And here's another way to look at this. What I'm really saying here is 4 times something will equal 24. So if you get scared of division problems, just think of it as an x, like a multiplication. 4 times something equals 24, okay? So I'm going to do the same thing and count up by my 4s that I did with my 7s, because that really is a good trick that I like to use. 4, 8, 12, 16, 20, 24. 1, 2, 3, 4, 5, 6. Looky there, guys. 4 times 6 equals 24, or 24 divided by 4 equals 6. Very cool. So I've actually been able to solve my problem. And my rule is to divide by 6. So I'm going to take a look at 42. I will do this one with you, and maybe you and your parents can figure this one out. So 42 divided by 6, and I just did 24, so let's see if I can do it with 42, okay? So I'm going to count up on my 6s. I know that 6 times 5 is 30, okay? So I'm already at 30, and I know that I would need 12 more to get to 42. 30 plus 12 would equal 42. So now I've got 5 6s, and then I would just need to add 6 times what would equal 12? Well, 6 times 2. So I know that I would need 5 plus 2 more 6s would equal 7. See, Mrs. Gardner is already showing you some kind of strange and new algorithms to figure out some of your math problems. So again, now I have 6, let me change to a highlighter, 6 times 7 equals 42. Okay? So I know over here I would need to put 7. Okay, folks, that is our lesson today on What's My Rule? I showed you what a function machine looked like, and we've talked through the different types of our function machine or What's My Rule routines. If you have any other questions, you can go to the Everyday Math website and look at a few videos or instructional pieces that are located there as well. You can also always email Mrs. Gardner, myself, at alicia.gardner@cardinalcomet.com. Thank you and have a great day.
Is that for your kids? Mom, is that for your kids?